For those of you who just jumped on, this is the Enacting Equity-Oriented STEM and REL Programs meeting. It is presented by the Cross-REL Group, Equitable Opportunities to Learn in STEM leadership area. So the first thing I would like to do, next slide, is to introduce our panelists. I'm going to start by introducing Dr. Megan Bang. Dr. Bang studies dynamics of culture, learning, and development broadly, with a specific focus on the complexities of navigating multiple meaning systems and creating and implementing more effective and just learning environments in science, technology, engineering, arts, and mathematics education. She focuses on reasoning and decision-making about complex socio-ecological systems in ways that interact with culture, power, and historicity. Central to this work are dimensions of identity, equity, and community engagement. She works closely with Indigenous communities. She conducts research in both schools and informal settings across the life course. Welcome, Dr. Bang. We also have the privilege of having Dr. Tamara Clegg with us as well. Dr. Clegg is an associate professor in the College of Information Studies at the University of Maryland, where she's the director of the Info Design BA program. She also co-directs the Youth Experience YX Lab. She received her PhD from Georgia Tech's College of Computing and her BS in Computer Science at North Carolina State University. Tamara's work focuses on designing technology, including social media, mobile apps, e-textiles, and community displays to support life-relevant learning where learners, particularly those from underrepresented groups in science, engage in STEM in the context of achieving personally relevant goals. She seeks to understand ways such learning environments and technology support STEM disposition development. Tamara's work has been funded by the National Science Foundation, the Institute of Museum and Library Studies, and Google. Welcome to you both. We're going to start today with Dr. Bang providing some background and context for this work together. I'll turn it over to you. Actually, one last thing I want to say, next slide, please, is just that both presenters will consider the questions to frame their work, specifically those factors around equity and STEM education. You'll hear more on these bullet points across the two presentations as well as in our breakout group. So thank you. And again, welcome, Dr. Bang.
Great. Thanks so much for having me. Just going to share my screen. And I'll start by just introducing myself. So, so my name's Megan. Thanks for that introduction. And really happy to share some work with you all today. And I hope I'm going to try to be really specific to connect to those specific questions, but I do want to just say I'm hoping that everyone will track. There's kind of implications for those questions across everything I'm going to share today. I know some of you actually, I noticed, but I don't know all of you. So I thought I would start with just telling you that my work and what I'm really thinking about these days is trying to really be clear about what I see as a central possibility and challenge of the 21st century. And that really is thinking about how are we creating educational systems that help human beings live in and transform the Anthropocene towards just culturally thriving and sustainable communities. So I ask questions about what forms of teaching and learning do we need, and what forms of teaching and learning support adaptation, resilience, and thriving in the coming decades. So I've really been trying to think about not only what do we need to achieve equity in the systems as they are right now, but what sorts of approaches to STEM education do we need given our challenges. And today I'm going to really try to give you some high-level ideas that I think with, and then give you a really concrete example of a project that has some features that we think are worth thinking about. So in my work, there's kind of a couple of really big ideas. As you heard, I study core cognitive models of human reasoning about the natural world. And across all of the work that I do in the design work are really, this really core idea that you should know is, I think a lot about how human beings conceptualize the natural world in what tend to be two models. One is the apart from, where human beings are distinct and separate from the rest of the natural world. And the other a part of, where human beings think about themselves and reason about the world as if they are a part of it. People have studied this, I'm not the only one, and there's really sound evidence to demonstrate that if you have an a part of model of the natural world and human beings' relationships, you tend to reason in systems and you tend to make more sound, sustainable decisions. For me, this has been at the core of these bigger issues that are related to socio-ecological systems, which the image on the right is a framework we use with teachers. And so a lot of our work is really saying, how do we engage kids in learning about the complexity of complex socio-ecological systems? But I want to be clear, the one thing that I think that hopefully, I think you'll probably hear across both Tamara and I's work is that we often do these things and don't take seriously how power and historicity is always shaping activity. That there is not an absence of power or how history is shaping the current moment. And so we really think about, how do you support educators in thinking about and managing that kind of complexity? To be clear, our current forms of education are built on and teach apart from models of nature-culture relations. So much of the work and thinking about equity in STEM education is really transforming this core relation. Schooling is primarily an indoor activity. Our representational ecosystem is based in apart from models. You all can Google ecosystem and see how many pictures of humans are a part of those ecosystems. We've structured content learning in terms of being really focused on apart from models, and for example, through lab-based infrastructures. And I'm not suggesting we shouldn't do lab-based science, but actually the full complexity of professional science includes field-based components, and it's largely not incorporated in K-12 systems at all. And partly what I'm really after here is that we have cultivated fragmented human-centric reasoning and unsustainable decision-making as a norm. In fact, there's lots of good evidence that there's been a devolution of human knowledge about the natural world since the 1950s. That's a bad sign, given the kinds of things that we're challenged with in the next century. And I think the last thing that I just like everyone to hold is that people have studied that we've created a systemic sedimentary bias that is creating multiplying health effects, including mental health, not just physical health, but including mental health, that lots of fields are starting to discover. And in fact, what we can see happening with our young people is that our youth know that there's a core problem with our nature-culture relations. Reports around climate anxiety and lots of other things have skyrocketed in the last decade. And what youth really want is an education that prepares them for being change makers and contributors to the world. In our work, we think that right now, we often think about in terms of economy and narrate in terms of jobs, not contributions to families and communities. So one of the key things for me is expanding the purposes of STEM education and the ways we present what the purposes of STEM are to learners in order to really expand equity. And because I can never not say something about this, really, if we look at the kinds of increased emotional distress that is being expressed across young people, we really need to think more than just social emotional learning. And I recognize that it's complex these days. In our work, we really don't just talk about social emotional learning. We talk about what are the relational and affective landscapes that we need to cultivate in learning. Should kids be able to feel joy, wonder, awe, interest while they learn? And in our work, we're really serious about understanding how is it systemically that we have failed to do that. On the right is an unfortunate chart about suicidation in adolescence. And American Indian Alaska Natives experience the highest rates of suicidation in the country. And part of what I think is really important, and that is to recognize how are we systemically producing some of these kinds of outcomes in youth. And partly right now we are in a system that produces systemic absence of Indigenous peoples and our lifeways, including knowledge systems. In the US, only 50% of states require teaching about Indigenous peoples, and 87% of those standards are pre-1900. We teach people to think about Native people as past. And if you're a young person and you can't see an authentic self in the present or a potential future, that is one of the key things that increases anxiety and distress. And just to say, we only have standards about Indigenous peoples' contributions to the world in social studies. So this is only about social studies. Never mind what it might look like in STEM disciplines to include and ensure that kinds of representation. What we also know is that it's leading to a problematic view of science. So it's not just in social studies that we matter. I show this map up on the left wherever I can. That map, the purple, are Indigenous territories. Currently, Indigenous territories contain 80% of the world's biodiversity. A quarter of all land is in Indigenous hands, but 95% of climate change hotspots are in Indigenous communities. So if we're serious about a STEM education that might also be for equity and justice, if you don't know about Indigenous peoples, then you're ill prepared to navigate the socio-scientific issues that are facing us. So for me, this becomes a really important thing to say. So what is K-12's responsibility? Really excited about some of the White House commitments that have come out in the last year or two to say that federal policy has to elevate and engage Indigenous knowledge, not just people, but our knowledges. And there's remarkable things happening at the edges of disciplines. There's this cool article in Nature around how colonial history and global economics has distorted our scientific understanding of deep time biodiversity. These issues of inequality aren't just about access. They're actually shaping our very ways of knowing and the knowledges we can have. So for me, I think about that a lot and think about how is it that we transform K-12 to actually prepare kids for the complexity of the world as it is in ways that actually is beneficial to them too. So I'm going to move to try to give you a view of like, okay, here's an example, right? Those are big ideas. I'm thinking about them. There are lots of projects I do this in, but today I'm going to focus on one project called Learning in Places, which currently is focused in 4 states and is really a model of interdisciplinary field-based instruction. Shout out to the crew that helps. So just to say, it's a lot, and there's a lot of people that have been involved in this work since its inception. But what is it? So this is a model that we have co-designed over the last 8 years or so with educators, meaning both classroom teachers, informal educators, as well as educational leaders, families, and community partners. And it's a model that's really aimed at cultivating equitable, culturally grounded, socio-ecological systems learning and sustainable decision-making, utilizing field-based education in outdoor places. We're currently focused on pre-K-5, but in our current cohorts, we have middle school teachers, high school teachers, and we have undergraduate professors, professors who teach undergraduates that use our frameworks all the time. So what is it? And what I'm hoping to do right now is to show you some of the high-level kinds of things that are embedded in our models as you all think about what are key factors in your own models for achieving equity. So in this particular project, we have what we call our materials ecosystem, and you don't need to make sense of all this. I just need to give you a basic framework. Is that we have our rhizome, because I'm a plant nerd and really love them. There's also a little bit of philosophy and Deleuzian ideas under that, but I'm a plant person. And so these are the core principles, and I'll explain them a little bit. And then we have our frameworks that are really for educators. They're educator tools and also family tools. Our storylines, so we're aligned with a kind of NGSS storyline approach, and then learning engagements, which are more like traditional lesson plans, but we organize them as bundled sets, not as lock and step following. So our rhizome, I want to take a minute here to just explore the rhizome. We have 5 key components, and you'll see some from those big ideas all the way down into a project rhizome. And these principles and commitments are grounded in learning and developmental sciences, but they guide everything. And part of what I already said a bit about nature-culture relations, so I'm not going to say much here, but what I do want to say is that helping educators learn how to see power and historicity in their everyday interactions has been a key principle here. Most educators want to teach equitably, but have no idea how to do it, and aren't attuned to how they may be unintentionally replicating inequitable kinds of interactions in their classrooms, and or failing to disrupt power dynamics between their students that are also creating inequitable environments for students. So oftentimes when we think about this, we only think about the educator as sort of the point of intervention about these things. And really, we worked hard to recognize it's a lot for an educator to manage the multiple kinds of interactions that are happening in classrooms around these dynamics, and how do we prepare them. Part of what we do is we spend a lot of time really actually supporting educators to rethink how they understand culture, learning, and identity, as well as their relationships to families and communities. And I'm going to show you a framework about this in a few minutes. And then the last, of course, is field-based instructional practices. Educators aren't trained to teach outside, and I don't mean taking a class outside and sitting outside and doing indoor pedagogy. We just don't currently teach teachers at all about what does it look like to learn outdoors. In fact, we have systems who have taught kids and adults that the outdoors is for recreation, not learning. So those are our key principles. What I wanted to do today is to give you a sense of, so how do you make those really come alive, and what are the tools to do it? So I'm going to focus and give you examples from our frameworks and our storyline, and try to pop those a little bit. So I'm going to start with our storyline, and just as I show this to you, you should not try to make sense of all the details. I'm going to tell you what to see in it, or else you'll be overwhelmed. But this is our classroom storyline that we co-developed. And what I want you first to notice is that this inside the pink box is in many ways what I think high quality science instruction looks like now, and that many people are reaching for. This is a very typical cycle of inquiry or investigational practices that are aligned with NGSS practices and those enduring practices that I heard mentioned. The difference is we integrate some other components in this. So I'm going to say a couple things about this. So first, on the left side is we really engage in a series of should we questions, or what we call place emergent should we questions, where kids and educators, or learners and educators, really develop and cultivate a sense of wonder and awe about natural phenomena in the world, based in their schools and in their families and communities contexts, so that their questions emerge from a different affective landscape than they typically get to do. And they go through a cycle of investigation to answer those should we questions, which are really ethical questions that motivate the need for scientific evidence, for deeper understanding and learning, and move towards change making. So certainly communicating explanations and proposing solutions is where we kind of are. In our work, we actually get people to enact, right? They actually have to do more than just propose it. They have to try to make changes. The other thing that I just want to say about this is these questions, when they're place emergent and then they're making change, is really a core way to build an agency in people's lives, so that science is relevant now to making improvements in the world, not sometime down the line later once you've made it through high school. The last thing that I just want to say about our storyline to note is that on the top is the in the field. So we've been deliberate. We are not talking about field trips. So one of the things that I like to tell people is lots of people will be like, well, I take kids on field trips. Scientists don't take field trips. They engage in field-based studies. They go to the same places routinely. They collect multiple forms of data in places. They don't take a singular trip. And what we know is that field trips are not the most effective and don't have the most impact on learning anyway. So when we talk about field-based methods and in the field learning, we're talking about routine engagements in outdoor places as part of learning. The bottom is with families and communities. And I'll say more about this, but partly we've done this to really get at transforming educators' relationships with families and communities, and expanding that in order to create equity, we can't only think about learners. It perpetuates a kind of history of relations between communities and schooling that is at the base of a lot of inequality in the United States. So we'll get to more of that. But I want to say, so we have a ton of these frameworks. And essentially what happened is educators said, we have talked about a lot over the last 3 years. This is amazing, and I need help holding it. So we developed these frameworks. And our learning frameworks, and some of them were built along the way, but they really became ways for us to engage with educators' intellectual interests themselves. So these are not, these are shortened but big ideas that we talk about in I talk about with faculty and graduate students, right? Part of what we've been after here is engaging educators in the big ideas, but also making it digestible and usable in particular ways. So these frameworks connect to expert thinking, they connect to kind of sort of those core developmental learning and developmental sciences, but they also come with these appendices that help connect to kid thinking or vignettes of classrooms, and provide some self-assessment tools for educators that are not the kind that we typically do, in which it's kind of a high stakes self-evaluation. The one that I'm showing you here and why I want to push on this is what we call our ethical decision and deliberation question. Part of what is important about this, our ethical deliberation and decision-making framework. This was developed with a series of scientists and natural resource managers. And what I wanted you to see is that it's embedded across. It's not that students do things and then decide what that might happen at the end, is that actually this is an ongoing process. And partly what's important to know about this is these should we questions is actually core to civics, reasoning, and agency all over the literature. And we've embedded in science in ways that usually don't show up, but it helps actually accomplish all kinds of other aims that we typically have. I'm just keeping track of my own time and I'm almost there. This is another example of our frameworks called culture, learning, and identity. And part of what I wanted to say to this group is that sometimes we forget that culture and identity shapes thought and action, that we talk about culture and identity as distinct from disciplinary learning. And it's just not how the evidence plays out. It's actually not even how the framework for NGSS talks about it either. So part of the key issue is seeing not only the cultural strengths, but the intellectual strengths and the kinds of intellectual traditions children are developing kind of beyond privileged forms of thought. Really what I'm talking about here is expanding to recognize that children come with expertise connected to the phenomena we want them to learn about all the time. And this isn't true for just kids, it's true for adults like educators as well. Another example, and hopefully I'm giving you a couple of the key ones that I think matter, and I mentioned before, is models of family engagement. So one of the key things that I think we forget about is that we have a long history of tension-filled relationships between schools and families. In fact, the United States has a history of thinking that families of color, and often poor families, don't have the right skill sets to raise their children. And so we've engaged in a kind of deficit ideologies-based system, and we tend to be driven by compliance. In fact, truancy is a kind of criminalization of non-participation in school systems. And I'm not suggesting kids shouldn't be in school, but if we think about how these systems have really forced participation in systems as they are, and we think about things like boarding schools for Indigenous kids Indigenous communities didn't close until the 1980s in some places. Schools are not always the best places for our kids, and our families and communities know it. What we don't often help think about is how do we support educators and actually creating partnerships with families and communities to thrive. So what we've done is taken this framework, help educators really reckon with this and be able to think about their own language, their own assumptions about who cares about school, who cares about academic achievement, how are they seeing what kids and families can bring, and to develop a set of tools. Really, you need to move from ideas to particular practices, and we call these our family tools. And they're a key design feature in our work. And really, just to say, these are embedded across curricula, and it really increases educators' capacities to teach diverse learners because they don't need to know everything. They just need to change the relational conditions. And I know I'm coming to my time, so I want to just leave with some key implications. One, I really think if we're going to achieve equity, we should learn outdoors. I think we need to transform deficit ideologies and assumptions that are systemic and routinized in educational contexts, which means we need a new base literacy for educators to sustain this, especially understanding issues of power and inequality and their persistence. We should support interdisciplinary learning. Disciplinary divides aren't learner-centered or teacher-centered. They're actually a kind of division of labor that is for systems, not for people. We need to increase the kind of affective landscapes. And I would argue all wonder and ethical driven decision-making and STEM learning would make a huge difference. And I think that what we really also need to think about is removing institutional barriers will require more than increasing access or equal distribution to current forms of STEM learning. We really need to make space for bigger purposes and new models of high quality learning. And I will end there, but I think I turn it over to Tamara.
Hey, okay. Hello, everyone. So can you guys see my screen?
Yes.
Yes.
All right. So thank you. Thanks for everyone for the introduction. Thanks, Megan. Your work always inspires me so much, if not anything else, just to become more engaged with the outdoors myself, so that I can model that to my nephews and nieces and the people that come behind me, but also just in general, the approach that you take of learning and things like that. And so I think you guys will see a lot of common themes across our talk, and I'm excited about discussing it and sharing it more. So when I think about equity and diversity in STEM learning, I think one of my big approach is to think about, like, how can we help learners to integrate aspects of who they are into learning. And so so the question really that kind of guides my my talk is, how do we help learners to integrate and develop their own identities in STEM, and especially learners from minoritized and resource constrained communities. And so I take a twofold approach to this work. So first, I think about developing life relevant learning experiences for young people. And then the second aspect is really deeply situating learning into communities and community driven STEM experiences, which again connects a lot with what Megan just talked about. So I'll start with talking just briefly about life relevant learning and my approach to that. So with life relevant learning, I really endeavor to help to situate science and STEM learning in the context of youth's everyday lives, right? So the deeper we can get into who they are, to their culture, their experiences, and things like that, the better. And that's what I aim to do sort of progressively in my work. And so what I try to do, what I call scientizing, or help youth to begin to scientize their daily life experiences. And so when someone scientizes their daily life experiences, they think about finding practical applications to science and STEM. And when they see those practical applications, they begin to use science and STEM to achieve their everyday goals. And so in essence, what I want to do is help young people begin to see the world, see their world through scientific lenses. And so in my work, it's starting back in graduate school, I've always sort of taken a sequenced approach to this. So first is, really deeply understanding what is it that youth care about, young people care about, and then within those contexts, developing first what I call semi-structured experiments, and then progressing to more choice-day experiment investigations. And so what that means is that, we would situate STEM in a context like cooking that's relevant to young people's everyday lives, and then within that context, we say we help them to develop a set of sort of scientific tools or inquiry-based tools to use. So for example, we might say, well, we're going to do some cooking investigations, and we're going to see, like, what do leaveners do in baking, right? So let's try to make different brownies with different amounts of eggs, or let's make the same cookie recipe but use different leaveners and see what happens as a result. And so once learners have those tools to do those types of investigations and experiments over time, then we begin to say, hey, now we're going to give you agency to choose what kinds of projects you want to do. And so in the context of kitchen chemistry for my dissertation work, what that meant was that youth could bring in their own recipes from their own families and their own cultures, and they could use STEM and STEM inquiry to perfect those dishes according to their own personal desires. More sort of later on in my work, this took the form of developing other types of tools and systems. So for example, the BodyViz system was a set of e-textile tools that we developed that help learners to sense and visualize their physiological functioning, and then use that for investigation. So with BodyViz, learners strapped a bioharness around their waist, and the bioharness could actually detect in real time learners' heart rate and breathing rate, and it would project this data on an e-textile shirt. So you can see the heart will light up according to the heart rate, the wearer's heart rate, and the lungs will light up according to the wearer's breathing rate. And additionally, learners up to 6 learners could wear the bioharness at the same time, and their heart rate data will be shown on a large display in a classroom or informal learning setting, so they can compare and contrast their heart rates in real time. And so you can see that here. And so as we've taken learners through that sequence of semi-structured investigations, where we sort of help them develop investigations and learn about what an investigation is and how they can carry it out, to developing their own investigations, we've seen young learners as young as first graders develop their own investigations and begin to adjust their own questions about how their heart rates are affected by the things, the activities in daily life that they care about, like running and jumping and doing different dances, scaring one another, and things like that. So really trying to incorporate inquiry into these daily life activities and inquiries that youth have, and in their own terms. So then coming back to the second part of this, which is situating learning in communities, I take what I call a third place design. So we aim to situate learning deeply within, not necessarily, but beyond, I say beyond the first place of school, first place of home and the second place of school, into third place community life or neighborhoods that learners are situated within. And this is where we take that deep community-based approach to learning. And so in doing this, we take an asset-based community development approach. We mentioned already asset-based approaches, and the asset-based community development approach takes that asset-based framing, saying that, all communities have assets that they bring that are helpful for STEM learning, that are helpful for just, communities in general. And what the asset-based community development adds to that is that this approach aims to support community development, not by having external people come into communities and sort of put interventions on learners, but to actually support and enhance what communities are already doing, the assets that they already bring. And so we specifically take this approach to support bridging learning in minoritized and resource-constrained communities. And so what we aim to do is to recognize and understand the assets that are already really flourishing in these communities, and to use technology to help connect them, to help amplify them, and things like that. So we took this approach in a project called Science Everywhere, which was a 7-year NSF-funded project, where we were developing social media and large display tools to help connect STEM learning that was happening in 2 neighborhood settings across home, school, and after school contexts. And so what we did was we worked deeply with the community, building on existing programs and things like that the community already had. We integrated these technologies into an after school program where the youth did life relevant learning according to just their interests, learning about science and cooking, learning about engineering through playing Minecraft and things like that. And the youth could use their mobile app to capture and share these experiences, and they could capture them at home, at school, and in these community programs. And then they could choose to make them public, which they would then be displayed to a large multi-touch display that was situated in the after school context, but also in the local school that the youth in the program attended. So within this context, our initial focus was always on, how do youth develop dispositions and identities in STEM as they have these experiences that science is propagated sort of through the neighborhood and connected across community contexts. But it was interesting as we came, towards the end of the program, we were talking to parents and teachers and community volunteers who had worked with us in the program over the years. And when we would be focused on asking them, okay, how have you seen the youth develop or the young people develop? They would actually always start talking about how they began to change and shift their perspectives of STEM and STEM learning through the process. So we wanted to understand this more deeply. So we did semi-structured interviews with the adults in the community context. So we talked to our community partners, we talked to parents, and we talked to volunteers who participated regularly in the program. And we wanted to understand what their dispositions were in STEM and how they shifted through and how they were influenced through as they participated in the community experiences with Science Everywhere. And so in our analysis, we found that there were 2 sort of major themes in terms of participant dispositions and their shifts in the program with adult participants. And specifically, we saw that there were some learners who identified more as what we call communitizers. They had strong relationships in the community, and that was what they were deeply valuing and caring about and what motivated their participation. Yet they often have more distanced views of science and STEM learning. And then on the other hand, we had traditional scientists who were more sort of subscribed to dominant narratives of science and science learning and what that looked like. And over time in the program, they shift their perspectives to understand how science could be done more informally and how it needed to be more sort of relational. So for sake of time, I'm going to just walk you through the example of one particular of these participants and the sort of the community-based story that emerged with this participant. And so that was our communitizer, our community partner in our local Eastern location or neighborhood. So that was Pastor Taylor, and Pastor Taylor was a pastor at Grace Covenant Church. He had been a pastor for over 15 years. He began working with us on the project before we even did the proposal. And so through developing the proposal, for the project, he was actively working with us, and he was motivated to participate in our program through his relationships in the community with researchers on our project team, but also with the young people in the community. He wanted to do more programs. He wanted the church to be able to do more programs to reach more youth and support them academically. And so in the first interview that we did with Pastor Taylor about a year or maybe a year and a half after the project had started, Pastor Taylor was expressing a more distanced perspective of science. So for example, he said, his greatest challenge in science everywhere would probably be my own lack of confidence in those areas of science. He's like, I understand. He's like, science is not really my lane. That's not what I do. It's not what I bring to the project. So he's like, I don't care, really to be honest about the science. He's like, I excel in the community part. That's what I bring to the program. But it was interesting because in the same interview, the interviewer asked him, the researcher asked him, well, do you ever make posts on the Science Everywhere app? And Pastor Taylor was like, no, I don't really make posts on the app. I don't really know what I would post. But he said, no, I did take this nice photo though. When we had to shovel some snow, he said, my son and I were finished and there was this nice sunset. And I wish I could have posted about it, and I probably still can, but he was like, he wasn't sure what he would say about it. So the researcher talked to him. She said, well, maybe you could say, like, why does the sky change color when we have a sunset? And Pastor Taylor said, yeah, that would be a good question. And he was like, you know what? And she said, yeah, you scientize the experience, Pastor Taylor. And Pastor Taylor said, you know what? I will try to scientize. So by the second interview, Pastor Taylor was beginning to negotiate how science could be connected to his community goals. So he was excited to see the community display at the church and how youth were using it to showcase community events that he didn't even really think about were connected to science. And so he began to see how some of those community events could be, connected to science and the science questions that the kids were seeing. And he was excited about how the community was gathering around the display as well. But he was still sort of having trouble relating science to his goals. So he said, you know what, I'm sorry, Science Everywhere, like, I'm probably not going to be interested in science. He was like, it has to be something that's like a specific part, of my goals. But then as he said that, one of the things that he thought about was like, were these experiments that the kids had just done over the past year around kind of sort of like Megan said, getting out in the environment and looking at water quality testing at the local, doing investigations of water quality in the local stream that ran behind the church. And as the kids did these investigations, they were learning about stormwater management practices, and they were showing how the water quality in the church needed some improvement. And so they actually suggested some specific stormwater management practices and installations that the church could do to better mitigate runoff into the local stream and help the water quality. And so, Pastor Taylor said, well, if I had to do something like that, maybe that might be connected to my goals. So he was beginning to kind of make that connection. But by summer 18, I don't even think this was an interview that we did with him, but we actually came to Pastor Taylor and we said, you know what, Pastor Taylor, the community, the kids, they really want to do something for the church because of the way that the church has, has helped us. And so we want to do some kind of project. And I think we were thinking like, oh yeah, maybe we do some kind of cleanup thing or, something like that. But Pastor Taylor said, well, what about those installations y'all told me we need to design, right? Like we should do those. And so we began to actually partner with a local and a watershed society And landscape architects at the Watershed Society actually worked with youth in Science Everywhere to co-design a rain garden that was specifically suited to the needs of the landscape of the church and the stream behind it. And Pastor Taylor actually worked to bring people together around the actual planting and constructing of this rain garden. So the youth and the architect from the Watershed Society came together with the high school volunteers that Pastor Taylor brought in to work with us. And Pastor Taylor actually facilitated a workshop for the church to learn more about stormwater management and the rain garden, and to actually get involved in the planting of the rain garden. And so in doing so, the community came together around this topic of installing and planting a rain garden and managing stormwater at the local church. And so in essence, it was sort of communitizing science. And so our work in this analysis and looking at this case, we think about, like, a lot of times when we think about science and science learning, we typically start with the science and we say, how can we take this science and, and sort of help communities to do science. But this analysis suggests that what if we start with the relationships in the community, and what if we begin to see how relationships can be strengthened through science endeavors like building and creating or designing and creating a rain garden in the local community. And our work with the adult participants and seeing the disposition shifts over time in ways that influence the STEM learning experiences, like you saw with Pastor Taylor, but also like we saw with parents working with their kids at home. As they saw some of the experiments and things that the kids were doing with the water quality testing or cooking or different things like that. As we also saw, the traditional science community volunteers who were more traditional scientists begin to think about new ways to better engage youth and more hands-on experiments that were related to their everyday lives. And they began to see how science needed to look different. Then what happened was that we saw a new sort of way to facilitate sustained asset-based community development as these community adults begin to think of new ways and new projects that they could engage the community in around science, and they began to see how science could facilitate their goals as well. And so, and coming back, I guess I kind of want to close out here, but I want to come back to this sort of twofold approach of life relevant learning and really deeply understanding our learners and what they care about and what their everyday interactions are, and really deeply situating science there, and then deeply situating science into the communities, right? The family life, the community life, and engaging multiple adult stakeholders in leveraging, like Megan said, leveraging the expertise of these different community adult stakeholders that they bring to bear in our learning experiences. And so I would want to just think about how can we do this more prevalently, right? Like how can we begin to situate learning in these spaces, but then also what types of our expectations or our infrastructures need to shift with respect to what this might look like, what science might look like when we actually let it be community driven, or when we actually let it be driven by the learner's interests and ways of engaging. And so with that, I just would like to thank my amazing collaborators on the Science Everywhere project and on the Body Viz project, and open the floor for questions.